Okay, ladies and gentlemen, let's start talking about exponential functions. Now, exponential functions are different from power functions in that power functions are x raised to some power, 3, 31, 314. Those are power functions. Exponential functions are going to be something raised to the variable. So it's actually the variable that's changing in the exponent, not some variable that is to some sort of exponent that it's fixed. So that's why we have exponential equations. Now, exponential equations come in just one of a very few varieties. An exponential function is always going to cross at 1 unless otherwise adjusted. Reason being, if I have 3 raised to the 0 power, anything raised to the 0 power is 1. So in this case, I know it's going to cross here. Now, if I have 3 to the first, that's going to be over 1 up 1, 2, 3. If I have 3 squared, that's going to be over 2 up 1, 2, 3, 4, 5, 6, 7, 8, 9. And so it's going to look like this. So we have this situation going on. If I have 3 to the negative first, that means 1 over 3. Well, that's 1/3. If I have 3 to the negative second, that's 1 over 3 squared, which is 1/9. And so we have this situation. And it never touches the x-axis. It always just continues along the x-axis. So this is your basic exponential function. Now, that is if the power is or the base is greater than 1. So if n is greater than 1, then the graph shape rises from left to right. If, on the other hand, n is less than 1, that means you're going to have something as follows. If I have 1/2, and let's raise that to the 0 power. Again, that's going to equal 1. If I have 1/2 raised to the first power, that's going to be 1/2. 1/2 to the second power is 1/2 squared, which is 1/4. So we have this situation. Now, additionally, if you have 1/2 raised to the negative first, that's going to be 2 to the first. So back 1 up, 1, 2. All right, 1/2 to the negative second, that's going to be 4. So, if your base is greater than 1, it rises from left to right. So greater than 1 rises, less than 1 falls. So those are your two basic exponential graphs. Now, of course, we can change everything from there.
Excuse me for the interruption. I need the following students to the office: Brianna Bagley, Hannah Daly, Rachel Derhock, Madison Engel, Laura Hay, Carla Hoffreiter, Bridget Norman, Shanna C., Bailey White, and Amy Williams.
Let's go 3x plus 4. In this case, we're going to have our standard 3 to the x graph, but instead of going through 1, it's now been vertically shifted using our same rules up 1, 2, 3, 4, so it's actually going to cross at 5. So the new 0 is at 4 and it crosses through 5. In the case of example 2, what if I have 2 times 3 to the x? Well, again, if I have a standard exponential equation, the 2 was going to make it go up faster. So it's going to look like this. But if it looks like this on this side, it's going to get closer to 0 faster on this side. So it's going to get tighter. Again, if I were to put it to 1/2, it would get a little bit wider. So it's going to go up more. Now, if I did the following. y equals 3x minus 1, and the minus 1's in with the x. Now, because it's in with the x, it's a horizontal shift in this case. So instead of crossing 1 right at 0, it's going to cross 1 at positive 1. So instead of being this graph, it's scooted over 1 unit. Okay, so if I put all these things together, you can move it left, right, up, down. You can stretch it vertically. You can stretch it horizontally. And finally, y equals negative 3 to the x. Well, that's going to be reasonably enough. If I put a negative out in front of every other equation, it flips it vertically. It's going to do the same thing here. Instead of rising like this, it's going to go down. By the way, if I were to do example 5, y equals 3 to the negative x, now the negative is in with the x, what it really does is instead of taking 3 to the power, it's really flipping this over every single time. And so it would be like 3 to the negative first, 3 to the negative second. And we'd already seen that in that case, if it's 1/3 to the first, 1/3 to the second, it's going to fall. So instead of rising like it should, the negative up here basically turns it over, making it fall just like we talked about earlier. And it does make sense because if the negative is out in front, it flips over in the y. If the negative is in with the x, it flips over in the x. And so it flips this way. Okay, so some basic graphing. The last piece of the puzzle is to talk about the natural log. So if we just have y equals 3 to the x, the base is 3. If I had y equals 2.718281828 and then raise it to the x, it's going to look almost identical to the 3. However, because the base is different, it's going to have a slightly different curve to it. With a slightly different curve, it's going to obey all the same rules, but because this number comes up so often, we say that this number right here, we give it a special name, just like pi is 3.1415, yada, yada, yada. E is 2.718281828. This is called the natural log. And in fact, E is going to be the inverse natural log. So all that is a number that means this. That's all that changes is it uses a specific number stored in your calculator, and it is simply stored right here above the natural log button. So you hit second E, and you can raise it to whatever power you wish and graph it. So with that, you have the graphing for exponential functions.